All right, let's look at lesson 7.2, systems of linear equations in two variables. So in our previous lesson, we used substitution and graphing to solve for our variables. In this lesson, we're going to use a method called elimination. So our objectives are to use the method of elimination to solve systems of linear equations in two variables, to graphically interpret the number of solutions of a system of linear equations in two variables, and to use systems of linear equations in two variables to model and solve real-life problems. So, needless to say, today we're going to be looking at linear equations and solving for our x and y values. So let's look at the first example. Here we have 2x minus 3y equals 7 and 5x plus 3y equals 0. For this process called elimination, you want to eliminate either your x or your y values. If you look here, our y's, if you were to add them together, they'd cancel each other out. So we're going to go ahead and eliminate them. We did that because when you add negative 3y plus a positive 3y, it equals 0, so it's eliminated. Let's go ahead and add the rest. So you get 2x plus 5x is 7x, and 7 plus 0 is 0. Nope, is 7. Solve for x, so x equals 1. X is 1 is going to be 1 for both equations. So it doesn't matter if you substitute it into equation 1 or equation 2 to get your y. Let's go ahead and substitute it into equation 2. So we have 5, x we just saw was 1, plus 3y equals 0. So here you have 5 plus 3y equals 0. If you subtract 5 from both sides, you'll get 3y equals a negative 5, so y equals a negative 5/3. So your point is x comma y, or 1 comma negative 5/3. This is your point of intersection. If you were to graph both of these functions, this is where they would meet. So that's your solution. Let's try another one. Here you have 3x plus 4y equals 11, and x plus 2y equals 5. So here, it's a little trickier to see what you can cancel out. But we can multiply one of our equations by negative 3. We're picking negative 3 so that our x's will cancel. You need to make sure you multiply every single value by negative 3. So we're going to get a negative 3x minus 6y equals a negative 15. Every single value. We're going to rewrite our first equation without changing it. So now you can see if you added these two equations together, your x's will cancel each other out. Go ahead and add the rest. So you get a negative 2y equals negative 4. Divide both sides by negative 2. So y equals 4. Nope, 2. Doesn't matter which equation you sub this back into, so let's go ahead and do the second one. X plus 2y is 5. X plus 4 equals 5, so x is 1. So your solution is the ordered pair 1, 2. So that's where these two graphs intersect. If a system of equations has at least one solution, then it is called consistent. So this is important. This system of equations is consistent because it has a solution. All right, let's try another one. So this would be your third example. Here you have x plus 3y equals 5 and a negative 2x minus 6y equals 1. What do you think you would multiply the first equation by so that it would cancel? How about 2? So you get 2x plus 6y equals 5 for that first equation. your second equation, you get a negative 2x minus 6y equals 1. We haven't changed it at all. I'm just rewriting it. But look, your 2x's cancel out, and so do your 6y's. So you're left with 0 equals, oops, let's change this to a 10. We're going to multiply the whole thing through by 2. So 0 equals 11. Does 0 equal 11? No. Therefore, this system has no solution. This is what the graph of these two functions look like. They're parallel lines. So therefore, they're never going to intersect anywhere. So they have no solution. Last one, example 4. Let's go ahead and rewrite our first equation with fractions. Actually, I think we're going to leave it. We're going to multiply our bottom one by 0.25. We're going to do this because we have a negative x here. So by multiplying it, we'll get a negative 0.25, so our x's are going to cancel. So I'm going to rewrite my second equation being multiplied by 0.25, and it's going to give me negative 0.25 x plus, let's see, 0.25 times 2. So silly. We knew that was this, so it's just 0.5y equals negative 4. Let's check that. It's been a long math day. 2, 8, 9, 10. Wow. Not negative 4 at all. All right, so that's going to be a negative 1. Let's get a bigger eraser here. All right, so let's take our first equation. We're going to make this red. So that's 0.25x minus 0.5y equals 1. Let's look. We're going to cancel out our x's. We're going to cancel out our y's, and we're going to cancel out our last part. So therefore, 0 equals 0. Let's look at the graph of this and see what we can conclude. The graph of these two functions is actually right on top of each other. So because it's the same line, we say that it has infinitely many solutions. There are infinite number of possibilities for where these two lines intersect because they are the same line. So here's just a quick reference. So consistent solution would be if there's one solution, or like the last one we did, infinitely many solutions. Inconsistent is like example 3, when your lines are parallel to each other. All right, here's one I want you to try for homework tonight. Let's see. Got 2x plus 4y equals 8, and negative x plus 2y equals 10. All right, so go ahead and solve those and see if you can come up with a solution using combination. Here's one more. Negative 3x minus 12y equals 36, and x plus 4y equals a negative 12. All right, good luck with those.